Okay. Okay, folks, let's go ahead and get started. Hello, everyone. You all set? We ready to go? All right, cool. Are we doing the live stream? All right, awesome. Okay. All right, we are all set. Hi, everyone. My name is I'm fresh from Lake Tahoe. I've been on vacation and just got down here just in time for today. Completely forgot my shoes. So if you can see, I've got flip-flops. But as we say, meetups, anything goes. So anyway, thank you for coming tonight. I've got with me my organizers, and we've got Alexi and we'll give them a chance to say something in just a moment. A couple things I wanted to do is intro to the AI Alliance, and then we'll move right on. How many of you have heard the AI Alliance before? Okay, if you've been here before, you probably have. Quick note about the AI Alliance. We were started by IBM and Meta. Interesting companies to get together, right? Yeah. Well, we both believe strongly in open source and AI, and we're doing our best to make that a reality for anyone who wants to do that. And so an example of what that looks like, of course, I'm sure you've seen and heard about Llama. And there's, they've got many models now. It's all open source or, close to open source, and you can use it however you want. There's also Llama Stack, which you can run AI applications and agents on. It's got lots of APIs for you to use that empower your AI applications. And then there's lots that goes around that. So there's a lot of open source tooling and servers like MCPs and all that kind of thing. So how do you put them all together? What are the different precautions or technologies that you need to implement in order to make it work well? For example, tonight we have a great topic on that note about evaluations. But there's all sorts of things. There's loops, feedback loops to make your agents better. Those are all the things that we are doing in the AI Alliance, and we'd love for you to join us. So if you're interested in finding out more about that, there are now 180 different companies involved in the AI Alliance. And you can check us out at thealliance.ai, or you can also go to our GitHub repo. And for this crowd, just go to our GitHub repo. You can see the different projects we're working on there. And we are getting ready to launch the Open Agent Lab, which is where we'll be doing a lot of the projects related to agents, of course. MCP projects are going to be a heavy focus. And we'll probably do an event just on that from the AI Alliance here in the next month or so. So by being here, you'll probably get an email at some point letting you know about that. So I'll move on for now. The other thing I want to mention is that if you are interested in speaking here at this meetup group, we get folks from our audience who have interesting things to say, and sometimes we give them an opportunity to say it in like a lightning talk. So come and reach out to one of us afterwards if you do, or you can follow up with us via the Luma email that you got. Okay, so I guess the last thing I want to say is that me personally, I'm very interested in engaging with our audience and giving you more opportunity, not just to maybe give a lightning talk, but also whatever else you're interested in. I have a project that I'm working on called AlleyCat. It's like a RAG-based application, but we also it's all open source, and it gives you the tooling to scrape a website and bring all the data into your vector database, and then of course have a chat with that. And what I'm doing with that project is taking it on a journey to not only be RAG, but also be agentic RAG, and then eventually become an MCP server, and so on and so forth, and just take it down that path. Eventually, I'd like to get it to the point where it's self-learning. So as it pulls in more data and as more people use it, it learns and just gets to the point where it learns on its own. So if you're interested in that project, come see me. Or if there's anything else you're interested in talking about, just come see me afterwards. Okay, with that, I'd like to pass on the torch to Max.
So, thank you, Dave. So first thing is Priyan Jindal here? Did he arrive? No, from Arise.
Okay.
Okay, so we'll do another call after. So I'm Max. I am a distinguished engineer at IBM Research, and day to day I do AI agents research. but also trying to apply agents to quantum. So if you're interested in talking about that, find me. I have a long history in certainly computer science and at IBM as well, so if you want to talk about that as well, that would be cool. But let me tell you a little bit of what's coming up, because that could maybe give you some ideas. If you know somebody or if you have a talk, find one of us and convince us that you should be on stage. So this month is evaluation. We kind of have it all planned, okay? So I'll give you a teaser for the next 3 months. Next month is gonna be AI in production. So if you have use cases or, importantly, customers using AI agents in production, so AI agents specifically, then talk to us. So that's gonna be next month. The month after that is gonna be AI agents in the workplace. So these are agents replacing you and I. Or maybe if you have ideas against that, that would be also welcome. So let us know. And then after that, we're gonna do AI agents engineering. So that probably would have been a topic we should have done early, but I think at this point, all the frameworks are sort of stabilizing. So that's gonna be the next 3 months. So any ideas about this, find Dave, myself, or Alexi, and let us know. So, Alexi.
Thank you, Max. If I can get this tab up. So, my name is Alexei Krabarov. I'm the AI committee architect at Neo4j, the graph database company, and also GraphRay company. And I also am the founder and organizer of Bay Area AI, which is the oldest AI meetup in the world, and AI by the Bay, which is the oldest independent AI conference in the world. And I have a question for you guys. Who studied computer science in school, in university? Who used computer science textbooks? Who used Russell Norvig textbook for AI? Wow, very few. Interesting. So that actually was a very interesting textbook. I started my grad school using its first edition. Now it's apparently it's like on fifth, different color. But it says AI, the modern approach, and at the little corner it said, an agent book, right? So agents were around at least since 1995. So why I'm asking this? Because AI by the Bay is, again, the oldest AI conference, and we had Russell Norvig speak 2017 edition when deep learning just came up to speed. And now we have Peter Norvig, who is the head of AI at Google Research, keynoting it again in November. So I just wanted to share that this conference is happening in November. And some of the first rows have this little thing on your seats. So we're going to do a raffle. Basically, don't throw it away. So 2 of them have numbers. If you look at yours in the back, throw it out. So we're going to have 2 free tickets to that conference in November. It's basically the best startups and enterprises in open AI in the world and Bay Area for sure. So that's one thing I wanted to say. The other thing I wanted to say is basically we have, as other speakers mentioned, we have these meetups happening monthly. Come September, we're going to probably have 2 because Bay Area is, again, going to be scheduled regularly. So we're very, very interested with agentic kind of landscape. We want to take a very rigorous and systematic approach, right? Like there's so much activity, so we really want to think, okay, like people have different definitions of agents. Are they planning? How big a part of it is a distributed system for the agent, right? Because Python is not really strong for distributed systems. We have a bunch of frameworks which are coming over from JVM, now being rebranded as agentic. They were actor frameworks like Akka. So I think it's an amazing time in AI infra, right? Like agents are not independent. They sit on top of infra. They sit on top of observability. The very strong focus for this conference is how do you plug it into the enterprise stack? Enterprise are not going to drop everything, set up a bunch of PIP packages, right? They're going to run Kubernetes. They're going to run JVM. So we see a lot of frameworks coming in built in Kotlin, like Mbabel from Rod Johnson or Spring. So we're going to have a lot of very interesting which wants to break into enterprise market. We believe that what's going to happen. I've seen a slide from Cattle get agents. Like this is what's actually going to happen, right? An agent is going to be another tool in the stack of enterprise software, and will be any idea? One word, 4 letters. Code. Right? The standpoint of letters is just so. If you're how do you kind of break into legacy stacks, how this is going to unfold, you can come to this conference, and also you should present our meetups, because reliable AI is going to be one of the topics of housekeeping rules. This is a very long room. People get tired. Obviously, we have long, deep technical dives. There's a noise in the back. We're going to figure the noise. We ask you, don't make noise in the back. It's very easy and interesting to have networking in the back, but if the talks are ongoing here, you can network outside, because this is very disruptive, and you think it's not carrying, it's actually carrying. So we ask everybody to sort of keep the voice really, really low in the back, because we can hear everything, and we're going to come and ask you to kind of be quiet if we hear a lot of noise. When pizza is going to arrive, it's very difficult not to keep the noise up. We'll see what happens then. But let's kind of hold, until this. We have very dense program. And if, for whatever reason, our third speaker is not showing up, we do this 1-minute hiring announcements. So we ask people to come and say, I am a startup, I am hiring. You'll get really 60 seconds for this. If you're interested in this, we'll announce this, and we'll just line up people up and just boom, 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 we'll go through this. It's a very good exercise to kind of see what's going on in the scene. So if you want to hire people, or you have a 60-second announcement, it should not be a sales announcement. Not like, I have an amazing agentic framework, it's better than anybody else, buy me. No, like, we're not doing this. But if you have an idea, if you're hiring for a startup, we can do that, all right? So that's all, and now, yeah, I already did, yeah. So if you have one of these cards with the numbers for the free tickets to AI by the Bay, come find me, or email info@bythebay.io. One of these cards should have one of these numbers.
Let me say one more thing. So very quickly, as you will see that both Alexei and I are photographers, yet another thing we do. Pretty serious. I have a show coming up next year, but I'll talk about that some other time. So you'll see me taking photos. If you don't want to be in a photo, just tell me. I'll just not put you in there. But they should be good. So.
But you can get a very beautiful Leica photos made professionally if you agree to that.
Oh, hey, one last thing, guys. Hey, by the way, today was our first event where we had over 1,000 people registering for this event. Yeah, yeah. So there definitely is demand for this. Unfortunately, we can only let about 600 registered be accepted, and usually about 33% of those people show up. So that's why we're at about 200. But yeah, there's definitely a lot of demand for this. And to commemorate that, let's do a quick photo with our background. All right, speaking of photos, here, get right here.
Oh, in a minute.
All right, cool. All right, there you go. Everyone smile.
Yay!
Cool. All right, then let's go ahead and move on. We'll go into the talks. All right, so what y'all came here for. All right, so our first speaker is a lightning talk. It's going to be Ranjan Sinha. He's an IBM fellow, and he's here to talk about a protocol called Natural Language Interaction Protocol. Come on up, Ranjan. All right. Okay. And do you want to use this or this?
I'll probably use that. Just one sec. Yeah. It's good. Okay. Well, hi, everyone. It's great to be here. I'm Ranjan from IBM Research. And thank you for the opportunity to introduce the Natural Language Interaction Protocol, also known as NLIP, to this community. Now, the original NLIP effort started in March 2024. The ECMA initiative started in December 2024. And ECMA is the organization that standardizes application-level protocols. And this project is also affiliated with the AI Alliance. So I'm representing the NLIP Technical Committee for this session. Okay. The researchers from the industry and academia are helping to design a universal open protocol, one that allows AI agents to interact naturally, securely, and intelligently, regardless of who built them. So you see some of the industry and our academic collaborators. Okay, so what's the motivation? So we know that there will be several intelligent software systems working within an enterprise and across an enterprise, and of course, on the web. The agent systems will have access to generative AI technology in a variety of modalities. And these agents need a common standard protocol to communicate. Now, the potential of the internet was unlocked by the creation of the Hypertext Transfer Protocol, the HTTP. So to unlock the potential of generative AI, we will need an equivalent ubiquitous protocol like HTTP for agent communication. And so the current state of protocols and this design may result in complexities and challenges with integration, interoperability, version management, and so on. So NLIP provides a simple, and I'll show you a schema how simple it is, open, standard, common protocol for apps, agents, and services to communicate with each other and to humans. But it assumes generative AI capabilities at both endpoints. And it follows the multi-turn request response paradigm to ensure that the meaning is refined and well understood. It's very similar to how humans interact. Say if you go to a bank, you might visit the bank teller and provide a request to the bank teller. The bank teller is not very clear on the request, might ask you a question and you respond back. And then eventually the job gets done. This follows a very similar paradigm. Now, some of the obvious requirements for a protocol is it needs to be secure. It needs to have this various safeguards, such as data privacy and data usage policies. It should be implementable across underlying transports and API styles. It should support multimedia content exchange. It should support multiple languages. It should be efficient. And of course, it needs to be standardized in an open forum so that the community can contribute ideas. Now, the application level protocols that we heard from in the prior Alliance meetup, it defines a structure. You'll see the diagram on the top right. The agent A on the left, agent B on the right, and the message over the wire, they have defined the same structure. That's the handshake. But it can force a rigid API. It can have version upgrade issues, limits extensibility, and a tight coupling of systems as well. In contrast, NLIP allows structure independence. So you can have a structure being used for agent A on the left, a different structure for agent B on the right, and a different structure for the message on the wire. As long as the meaning and intent is the same, this will work. So the information exchanged on the wire can be translated to a structure that is local to each communicating party and uses generative AI for that translation. So what's the scope? It supports communication between two agents and between a human interface and an AI agent. And what's out of scope are anything to do with legacy software and anything that doesn't use generative AI technologies. Now, there are multiple single vendor protocols that have been proposed. You heard Anthropic MCP, IBM ACP, Google A2A in the last session. Then you have Cisco Agency, and there are several more. If you review some of the surveys that have been done of the last survey papers of the last few months, there's quite a few more protocols, and a lot more will be emerging. Now, NLIP can operate with them in two ways. Mode A is NLIP provides an outbound API, and the single vendor protocols can provide the southbound API and using an LLM to do the translation. And in mode B, NLIP can interoperate across multiple vendors, and each of these could have a single vendor protocols, multiple agents, different frameworks, but you can use NLIP for all these interoperability across these domains. Eventually, we believe that the industry should converge to an open standard, such as NLIP, or influenced by it. And it's very similar to what happened in the 1990s. You had every business app had its own protocol, custom client, bespoke integrations. Eventually, HTTP emerged as a simple, uniform, extensible protocol. And it unified the internet experience under the web browser. And it really made it simple from an application delivery perspective, interoperability, and unlocked internet applications. Today, we have a fragmented ecosystem of AI agents, tools, APIs, and proprietary integrations. LLMs and AI agents don't all talk the same language, and AI agents and chat are becoming a common interface for business solutions. And if you can define a single standard protocol, let's say for HTTP for intelligent agents, it can unleash scale and collaboration for agentic AI applications. So there are similarities. So I spoke about the simplicity of the nlib schema, and so this is pretty much the extent of it. And I'll provide the links on the last page, but there's a link to the nlib schema. So a bit deeper dive into this. So the nlib messages, I've highlighted one field called the content, because that's really conveys the key message. The rest, you could consider them as metadata, supporting the content field. So the format, for instance, it talks about what kind of content, is it text or JSON or image or video. The subformat provides more detail on the format. So if it is text, provides the language. If it is image, encoding for the images. Content is the actual message, and label is a simple name or tag, weather info, for instance, if your content is what is the weather in San Francisco tomorrow. And we can use some of these labels to do some optimization, leading to fewer calls to various inference engines. Now, nlib messages can consist of a sequence of sub-messages, let's say text with attachments but in most cases, you really have one sub-message. Now, some of the salient features, its primary mode of interaction is natural language, and it's, as we have seen, it's really an intuitive human-centric communication. It supports multiple modalities. Structured text is supported, though it is not the primary mode of communication. There is no custom configuration. All configuration and policy exchanges are through natural language. And you can use different AI models at different endpoints, an IBM Granite for endpoint A and Meta's Llama for endpoint B and Gemini or whatever else. It's not constrained by it. Now, nlib is also not reinventing the wheel. It builds on tools that we already use. So it runs on top of secure communication, secure connections like TLS. It runs on top of some authentication system, uses the base standard transfer protocols like HTTPS, and on your phone or computer, the nlib library helps your app talk to nlib server, and the server can communicate with the business application servers for ordering and scheduling and whatever else. So nlib fits into the system we already have, just it's more natural and I would say ready for AI. So the current status, we are defining and standardizing under the ECMA TC56 umbrella. The draft specifications and initial implementations are available in the nlib project, and you'd find the QR code at the top. We welcome comments and feedback, and that will help influence future revisions. And we are targeting a standardization of this protocol sometime later in 2025. And so for more information, or you'd like to get involved, feel free to visit the GitHub and just contact us. Okay, so with that, thank you very much.
And we have time for one question, if there are any. Are there any questions? Way in the back. We'll let you go, since we never get the people in the back. Let's give you a shot. Hold on. Oh, hey. It's my guys.
Okay. Just curious, how does this compare to like the A2A protocol and other emerging protocols that are like more higher level interacting between like different agents?
Right. And so for one, it's structure independent. The second, it's uses generative AI for the structure independence. Then, in fact, I'm currently leading a work stream on evaluating nlib against several of these protocols, using looking into multiple dimensions and interoperability and efficiency and all that. So you'll get to hear a lot more on how these it compares with more metrics and more details in subsequently. But yeah.
Okay, great. Thank you very much. By the way, we'll be sending out links to all of the presentations and the video after the event, so you'll be able to review them. And now let's turn over to Max. You want to do the next introduction?
Thank you.
So as Claire is setting up, so because now our eye speaker is here, we may not have a lot of time for that 1 minute, but maybe maybe we can do 2 or 3, right? So, yeah, to this guy. You can bribe him. No, just kidding. It takes a minute. There we go. All right.
There it is.
Perfect. So it's a great pleasure to introduce Claire. I met her maybe 2 months ago at an AWS hackathon. I take part of these things. And I was impressed by 2 things, or actually 3 things that she mentioned. First, that she's a mathematician, statistician. I remember I hated statistics, but you have to learn it. So that's what she does. So that's number 1. Second is she presented Comet Opik, which I was blown away by immediately. And I told my team we should use it, and we are using it right now in production. And then the third thing is she flew in from Las Vegas, and there's a very good reason she flew in from Las Vegas, and you'll know why. So with that, Claire, thank you for coming.
All right. Hello, everyone. How you guys doing tonight? Awesome to be here. I'm a little bit short, but I think I can see most of you over this. Hello, my name is Claire Longo. I am a mathematician by training. I've been working in AI for about a decade, and I'm currently working for Comet, who built Opik, which is the open source tool for LLM evaluation. I also play poker. That's how I'm also monetizing my mathematical skills, and I am working on an AI app for that, but that's not what we're focusing on today. But if you do want to talk to me about poker, come see me afterwards. Today, I'm going to walk you through a project that I put together that uses Opik for LLM evaluations. I want to show you how Opik works. It's totally open source, but I've learned that the best way to really demonstrate its value is to show you how I'm actually using it in my own hands-on projects. So we're going to do death by PowerPoint for just a few minutes, and then we're going to jump into some actual code and working software. So I work on a lot of different personal projects. I find that it is, for me, the best way to learn all these tools. Some of you guys might be experiencing like tooling fatigue. There are a lot of different tools that are on the market today, and it's really kind of a main source of my anxiety is to stay up to date with it. But I found that if I just come up with a project that's something I actually care about or is useful to myself or one of my friends and use the technology, I will actually test the edges of it and learn it very quickly. So that's why I put together this recipe generator. I built the recipe generator because recipe generators are actually really, really hard to do with AI. I know a few people doing this in kind of different ways, and there's some common problems with them, and it demonstrated a really good use case for evaluation metrics, which I'm going to talk through. But before I go there, how many of y'all have built apps with Gen AI? Most of you, I love that. Who here is familiar with evaluation metrics or LLM as a judge? Quite a few. Okay, awesome. That's going to be the focus today. So this is what I put together. I'll go through a slide really quickly, but I essentially just used the OpenAI API. It's in a Jupyter notebook. This is a really simple project. There's an LLM prompt, and the meat of this work is really in defining the prompt, and the code itself is really quite simple. And then I integrated Opik through Python. It was really just a few lines of Python code to both collect my traces and define personalized eval metrics for this project. Here's what I learned about building good agents. There was 3 things that stood out to me. The first one is modular and role-based design. One of the things that I really love about agentic systems, when I see the design, it almost kind of looks like microservices, where you have all these different little nodes and each one has its own very specific task. When I first started building with Gen AI, I just shoved like everything into one prompt, and it was really ineffective because I ended up with a situation where if my system was breaking, I couldn't really pinpoint exactly why or fix it, and it was also just too much instructions for the LLM to really interpret and be effective. With agents, all the architecture that I'm seeing is very role-based and modular, so it really allows you to design it in a way that's going to lend itself really well for observability. Observability is the next piece. This is logging every step in your process, being able to debug, having logs of every input and output will help you visualize if something's going wrong, as well as layer in evaluation metrics. And then last of all is agent optimization. I think the earlier speaker was touching on this, or maybe 2 speakers ago, it might have been Dave. Talking about these self-improving systems. It's one thing to like build an agent that works and it looks great in my Jupyter notebook, but where I really want to see advancements in AI is that feedback loop, if we're actually improving the system from the new data that's seeing in production. So thinking about optimizing the prompt, the decision routing, things like that, that's where I'm really focused on agent architecture today. All right, so I'm going to jump into observability, which is at its core monitoring and evaluation metrics. But first, why is observability so important? I have a wonderful example up here that I thought was hilarious. But before I talk you guys through that, has anyone seen any weird issues with these Gen AI applications in the wild, interacting with them yourself or maybe in the news? What kind of patterns are you guys seeing? You can break it. They make shit up, I heard in the back. Yes? I'm always correct when they're wrong. Good for you. I don't need an LLM anymore. I can just ask you. It's very like validating, and when I tell it it's wrong about something, it's like, oh yeah, totally, and they'll just like, yeah, but like, was I right? I don't know. Yeah, I see that pattern as well. It's a very confident sounding system. Yeah, so what you're touching on there is hallucinations. So these things will very confidently and articulately tell you something that's completely wrong, and if we don't already know the answer, it's really hard to detect that. They're very suggestible. In this situation, GM deployed a chatbot. This was an LLM-based chatbot back in 2004, so I'm sure things have improved since then, but its purpose was customer service, so it's really purpose-built for something, and that's something we really need to evaluate these systems for. But it was so good at customer service that it kept a customer happy by selling them a Chevy Tahoe for $1. That's a great deal. So that's obviously probably not the intended use case here, and those are the kinds of things that we need to be measuring and detecting when these systems are live, but it's really hard to come up with like a metric to measure those kinds of like language-based issues. So that's where the LM evals come in. All right, so what is Comet Opik? First of all, it's completely open source. You can download it and start using it today. It is just a pip install if you're using Python. It provides that end-to-end model evaluation platform for AI developers like you and like myself. It's going to give you best-in-class LLM evaluation metrics, as well as experiment tracking and the production monitoring piece. So enough of me talking through slides. Let's go see it in action. So I'll show you, how does this look? Probably not so great for the back room, but I'll zoom in here. So we're looking at Python code in a Jupyter notebook. This is my recipe generator. Anytime I want some ideas for a recipe for something to cook at home, this is where I go. It's really quite simple code. You can see I'm importing Opik, which is going to do the traces and evals. I'm also using OpenAI API, very simple. And this is the meat of the code itself. It's just a simple prompt, and then you've got your nice clean call to the OpenAI API. So this is a very simple example, but you can imagine these like more complex agent systems. You might have multi-agents, you might have complex routing infrastructure. And at that point, it becomes very important to be able to have visibility into every step in that system. So that is what the opik.track is doing. So this is just a simple Python decorator. I'll zoom in so people can get a really good view of it. But all this is doing is this is indicating exactly what I want to log to Opik. And then when I run this, I can run a call through this, the logs are going to be automatically sent to Opik, and there I can create the eval metrics. So you can see here a good example of why LLMs are so difficult to really wrangle and make them good at these kinds of use cases. So I asked it for a BLT sandwich. That's pretty simple. Probably a lot of us know how to make that. And it generates a recipe that looks legit at first, but as I start to look at it, there's some things that kind of stand out as a little bit off. It wants 8 slices of bread. That is a lot of bread. I didn't say how many sandwiches, but it just decided 8 was the right number there. It seems like a lot of bacon, but that could be personal taste. But what this is indicating to me is the LLM is going to fail on some things that are really specific to my use case. So no matter what I'm building, whether it's a customer service bot like GM or a recipe generator to help me out at home, it's very nuanced to that use case where it's going to start to mess up. And in this case, I don't really have like an accuracy metric that I can just track over time. So I am left with this issue of like, how do I detect stuff like this? If I was actually going to deploy this live and give it to people, well, I'm actually charging money, I need to make sure that this is a high quality app that I can trust. And if it's doing stuff like this, people are going to start complaining, leaving me bad reviews in the App Store, things like that. So that's where the evals come in. Let's hop into Opik. So you saw how I was tracking the calls. So this is Call My Opik. Here you can see all my projects. I'm working on quite a few, but this is the recipe generator. And what you see here is every single trace that's been sent through the recipe generator. In addition to the inputs, the outputs, the date, timestamps, of course, there's also total tokens and estimated cost. These are very important things for me to be able to monitor, especially if I want this thing to go live. I want to make sure it's not going to blow up my AWS costs or anything like that. In addition to that, you can see correctness, and this is very customizable. I could choose to add or remove columns. But the thing I want to point out here is I have quite a few evaluation metrics that I set up. I have, oh, it's so hard to see there. I'll give you a different view of it. Let's click into one of the traces. So this is what the trace looks for a very simple app, but you can imagine for like a complex agentic system, you might have a lot of steps. It's just a single call through the system. If it's a RAG system, you're going to have like a retrieval step. Maybe there's a re-ranking step. So there's all kinds of different steps. And the ability to see the breakdown of each one, as well as the cost of each one and inputs and outputs is incredibly helpful. Here you see the actual LLM call. And in addition to inputs and outputs, I also see the metadata. So this has been really helpful to me if I'm experimenting with different parameters on the model or even different model types. But most importantly, I have feedback scores. Let's grab one. It's going to be a good example. OK, so on this one, you can see that I've configured a few eval metrics. So the first one to point out is hallucination. That's the most common issue with these LLMs, so that's obviously something I'll put on every LLM app that I develop. And this is just giving me a score of 0 or 1. Did it hallucinate or did it not? So now I actually have a numeric metric that I can track over time, monitor, set alerts on, and use to debug my system. Same with moderation. This is testing for fairness and bias. And then last of all is recipe quality. I'm going to show you how I created these metrics, and I think that's where it all kind of comes together. So let's jump into recipe quality. Yeah, I'll edit here. OK, so the recipe quality metric, as well as hallucination, moderation, these are LLMs that judge metrics. So I'm using one LLM to judge the output of my first LLM. And the reason I really love this, it's completely customizable. We saw the issues with my recipe generator app were very specific to that use case. Yes, I can test for general hallucinations too, but I really want to be able to detect those like weird issues like the wrong amount of the ingredients or maybe improper cook time. That's something very specific to my use case. And because an LLM as a judge metric is just a prompt, I'm able to tune this metric to detect anything that I want. So I actually had a lot of fun with it. I told this LM as a judge metric that it was Gordon Ramsay, and its job was to judge the quality of the recipe, and I told it to focus on the proportion of the ingredients, focus on skill level, and expected cook time. So now I have an LLM that is going to output a metric. Its output is constricted to JSON format, 0, 1, and I'm also asking for an explanation. So it's going to give me a number to track that's actually going to tell me, like, hey, this recipe messed up the cook time or something like that. So this is an example of how you can be really creative with the metric that you set up. because it's really just a prompt. And because I'm already logging the inputs and outputs, I have the total schema. And so I can identify exactly where I want this eval metric to run. I can run it on the trace level or the span level. All I have to do is create the rule. And then when I log traces, it's going to show up in this list here. And it's a bit hidden, but if you roll over the chat bubble here, you get a explanation of why it gave that score, which is really useful for debugging potential issues here. So that is everything I wanted to walk through. This is a observability strategy that I implement for really any LLM app that I put together. It's a combination of logging inputs and outputs, and then putting personalized eval metrics on those traces. Thank you very much. If you guys want to get started with Opik, I have a slide that you can scan to get there. This one. So it's completely open source. If you scan this, this will take you to our repo. You can contribute to it. We have like the best-in-class engineering team maintaining this. If you want to do PRs, collaborate with our team. Give us a star, and all it takes is a pip install and a few lines of Python code, and you get this integrated into your app today. Okay. Yeah. And if you have questions about it, you can find me on LinkedIn. Part of my job is to help folks like you guys get Opik integrated, so I'm happy to answer any questions, have discussions about these topics. Thank you.
Very good. Thank you. So any questions? I see one in the back. Oh, 2, 3. Okay, let me go here. I'll come back. You have time for questions. So. Yes.
Hey. Hello. Yeah.
Hi.
Hey, you had a point which is Gordon Ramsay, right? So how much of training to evaluate your recipe using that context, Do you need to upload certain informations about that character? This is how he's going to evaluate the recipe and use that model to further evaluate? I'm just curious. How did you go about that?
I want to make sure I understand the question. Are you looking at like training data for the evaluation metric, for the recipe, for the evaluation metric?
Yeah, that's right. Yeah.
Okay. Yeah, so the evaluation metrics, they're interesting because it's just an LLM evaluating an LLM, which actually introduces an additional source of uncertainty because you want to make sure that your evaluation metric is accurate in the first place. There's two things that I say to that concern. The first is that the evaluation metric itself is pretty much just directional. Like if you do see a spike in your hallucination metric, it may not be like 100% mathematically accurate, but it's going to be directionally accurate. Like if there's something spiking, there is something to debug, you got to go look at it. So for monitoring purposes, debugging purposes, I still love the LM as a judge metrics. The other thing is that the LM judge as a metrics are typically benchmarked, like the one for hallucinations. That prompt has been like run against some data sets where we have like tagged true and false positives or whatever we need there to actually know if it's correctly detecting the hallucinations. So that gives you like an idea of like, is your hallucination LM as a judge prompt working given that baseline data set. So you can find like a bunch of research and like benchmark data sets for creating these metrics. But if you're doing something like very personalized, like the recipe quality one, you'd probably have to curate your own benchmark data set for that.
Cool. We have another here, and then we'll go on.
So going along the lines of evaluating the LLM as a judge, do you have to use a different model for the LLM as a judge than for the actual application, or have you found it's okay to use the same model and you basically achieve the same results in terms of false positives, false negatives?
That's an excellent question. I'll just tell you from my personal experience, I was using the same model, and I actually learned from someone in a presentation similar to this. I gave the same talk, and he shared that he was using a different model, and I started doing that, and I just think theoretically it makes sense because you're introducing a slightly different perspective from that second model. So I've adopted that as a best practice. I haven't seen benchmark or proof or anything, but it just kind of makes sense. So generally, I'm generating with one model and then and then evaluating with another one. Good question.
One question.
One last one.
Yeah, I think you asked a good question. But the last one is when we are doing a multi-step agent and you have In each step, it is reasoning, it is giving an output and reasoning. Now, do you do eval all steps? If yes, then how do you control cost? And if no, then how do you control the outcome?
Yeah, so the question is, you have like a multi-step agent. I showed like a very simple system, which is a few steps, but you're thinking about something much more complex. I'm wondering if you should eval overall or each step. Great question. I do both. So on these, you can see I just have like 2 steps here. It's super simple, but I've written apps that have like 10, especially like a RAG where it's doing retrieval. You can easily, in Opik, you can place the eval metrics on the system as a whole at this top level on the trace, or on the spans within the trace. And so I typically do both. I want to know if my system's failing overall, and then I also want to pinpoint where. So it's a variety of metrics where there's an overall strategy as well as a strategy of eval metrics on each span within the trace. Oh, very good question. It does get expensive. The first thing is sampling, which we have in here. So I have an app that's probably going to go out at scale to a lot of users, and this is the way that I would do this. My eval 2%. It depends on how much data you're seeing, but the goal here is to catch general issues that are going wrong and correct them. So it depends on what patterns you're seeing, but if like 2% is enough to like get that graph and see directionally where the issues are, or if you have a small user base, 80%, but it allows you to control that sampling here.
Thank you very much, Claire. I appreciate it. Thank you, everybody.
All right, if you guys want to chat more, you can find me after.
Yes, you're going to be here, right? So find her. I think she's sitting over there. Thank you, Claire. Okay, so next speaker, if you can come and set up the next speaker. I guess it's Arise, right? He's on the back. Yes, he's here. Thank you. Dave? Yeah. Hey, man, do your job.
Okay, well, you're doing such a good job. All right. Okay, how many of you have heard of Arise? Yeah, okay, you should. Very good. So I met them about 1.5 years ago and at some hackathons, and they were one of the very first tools I saw where you actually got to see what was going on between the agents. And then they came out with an open source project called Phoenix. So I think that's what we're going to hear a little bit about today.
This window, because I need these speaker notes.
Put those off to the side.
Let me give you a little bit of background here.
Because if you project it, you know. Like
So Priyan is an AI engineer at Arise. And I'm going to turn it over to him in just a moment.
Not sure. I mean,
Oh, well, let's do another question then. How many of you have actually used something from Arise like Phoenix?
Yeah. So
I can like
Okay,
this
I'm gonna hit a few hands. Very good. All right.
split and then just
People actually doing real work. These are people doing real work.
yeah. So I'll.
Okay. You ready to take it over?
yeah.
And you might want to
Need to make sure it's showing up properly. Oh yeah, okay. Oh, I see.
So you can see the whole thing there.
All right.
So you have to see your speaker notes there? Or? No, it's like an exact mirror right now. Okay, you're good. Can you see your notes?
Yeah.
Okay, cool.
All right,
All right.
take it away.
Hi everyone, my name's Priyan and I'm an engineer and a DevRel at Arise. And today I'll be talking about how Arise is contributing to this awesome and emerging field of prompt learning. So at Arise, we've identified 3 main pains of building agents. The first one is collecting data on your agents and what they do. The second one is evaluating your sessions or the entire conversation between a user and an agent. And the third one is improving your prompts for your agents. So today we're going to be going in depth into improving your prompts, but I wanted to cover some of these other areas up front. So the first pain, you need to be able to collect data on your agents. So with Arise, you can do this in the form of traces. So if we take a look at this demo, here, this is a single agent system using LangGraph. And as you can see, we have agent executor, we have some tool calls using OpenAI tool calling, and we have this supervisor node right here. So you can specifically see traces to see what's going on within your supervisor node, and you can even attach an eval for handoff correctness. This is an example of an LLM as a judge eval, basically evaluating whether your supervisor node is handing off responsibilities to the other parts of your application correctly. And so now you've seen that we can trace these single agent systems, but what about multi-agent systems or multi-agent applications? For example, here we have a research agent that's working with a search agent and an analysis agent. So how can you sort of collect some data on that? So Arise also lets you collect data on your multi-agent applications also in the form of traces. So if you look here, this is a sort of visualization of your multi-agent workflow. You start off, you have a planner agent, you have some tools, you have a router, which sort of takes you to the different parts of your application. Here we have a planner agent, and as you can see, you can inspect. You can see it calls embedding models. It has some tools that it's calling. You can also sort of attach some evaluations for that planner agent with LLM as a judge evaluations as well. So for example here, it's just going to show you, this is your planner agent, the different paths it's taking. You can see it calls a tool. You can see it employs a router, and you can see some LLM as a judge evals attached on top of that. So evaluating individual LLM calls, agents, or tool calls is good and all, but what if you want to evaluate an entire session? So a session is an entire conversation between a user and an agent, which you can imagine involves multiple queries, involves different sort of agent workflows, different tool calls across every single every single part of that conversation. So what if you want to evaluate that entire conversation as a whole? Basically evaluating your entire system across an entire conversation. So Arise lets you evaluate your traces, so the entire sort of path of an agent application, and it also lets you evaluate your sessions, so the entire conversation. So first here we'll be looking at trace level evals. So for a specific trace, you can see the different sort of parts of this trace. You can see that it's employing a router, it has different tool calls, and you can see in an evaluation for that specific trace. Specifically here, this is agent trajectory. So agent trajectory is an LLM as a judge evaluation, sort of evaluating whether the trajectory of your multi-agent system within your trace was the correct trajectory taken. And as you can see, the LLM says it's an incorrect for whatever reasons it has, and you can see that in this explanation field right here. You can also evaluate your sessions. So as a reminder, sessions is your entire conversation between a user and an agent. So you can see here, you can attach an evaluation from an LLM, which is going to say whether this session was correct or not, and you can go through the entire conversation. As you can see, each of those were traces, so you can click into each of those traces and see the different tool calls or the whole agent pattern for each one of those traces. And so, sorry, one second. So with all this data that you collect on your single agent systems, your multi-agent systems, and your sessions, you're basically now well equipped to actually sort of test and improve your prompts for your agents. Now that you have data on what's going on in these different agent calls, your multi-agent systems, you can take a look at how changing different prompts would affect that data. And so for the rest of this presentation, I'm going to be talking about improving your prompts through prompt learning. So I'm going to be using this term system prompt a lot. So what is a system prompt? I want to quickly define it so everyone's on the same page. The system prompt for an LLM contains a general role or set of guidelines that your LLM wants to follow when answering questions. For example, if you want to use an LLM to build a poetry chatbot, your system prompt could be something like, you are a renowned poet, while the user prompt could be something like, write a poem about LLMs. So let's take a look at this tweet from Andrej Karpathy, who many of you guys probably know to be one of the world's brightest minds and influences in AI and LLMs. So basically what he said is, we're missing a major paradigm for LLM learning. And he called it system prompt learning. He says that pre-training is for knowledge, so training an LLM to have some sort of corpus of knowledge, while fine-tuning is for pushing an LLM to have some habitual behavior. But he says that a lot of human learning feels more like a change in the system prompt. You encounter a problem, figure something out, and then you remember sort of in fairly explicit terms for the next time. So you're sort of changing your system prompt. He says that it kind of feels like memory, but it's not the same type of memory you have in ChatGPT where it's storing random user facts. It's instead storing problem-solving strategies that would lie in your system prompt. And he says that with static system prompts for LLMs, meaning their system prompts aren't changing, that sort of feels like the main character of Memento, except we haven't given him a scratch pad yet. So basically, I don't know if you guys are familiar with the movie Memento, but the crux of the story is that the main character, Leonard, literally can't remember what happened to him 10 minutes ago. So he lives his life continually making these new decisions based on his static system prompt, which is like his general guidelines for like making decisions. His system prompt isn't changing as he lives his life because he doesn't remember his memories, which tell him how he made decisions, and he can improve his system prompt based on that. So he ended up using a scratch pad to sort of write things down, as well as like on his body, as you can see in this image. And so that sort of became his dynamic system prompt, which allowed him to, like sort of make new decisions as new things happen in his life. System prompts are key to building effective language models. In case you guys missed it, Claude's system prompt was leaked a couple months ago, and it is 24,000 tokens long, or 18,000 words long. I mean, it has been meticulously shaped into what it is now. Without a system prompt, Claude simply wouldn't be Claude. And unlike Anthropic, you guys probably don't have hundreds of employees or thousands of employees watching your LLM answer queries and meticulously editing its system prompt. To get a perfect system prompt, you need to manually test and analyze queries. You need to perform many iterations of analysis on sort of your LLM outputs and continuously improve your prompt. And so the bottom line is, if you want to automate the continuous improvement of your LLM applications like Anthropic, you need to automate the continuous improvement of your system prompts. So how do we improve upon prompts automatically? How do we automate this improvement of system prompts? So the most popular current approaches that come to mind are DSPy and meta prompting. So DSPy essentially relies on a metric that you are evaluating your LLM outputs on. Numeric metrics are fine as evals, and they actually work pretty well as evals, but conceptually, they provide little information into actually knowing how to improve your prompts. For example, you can tell DSPy that 70% of your LLM outputs are correct, and it's gonna sort of search for a prompt that pushes that higher to like 80%, but that individual metric telling it that only 70% of your outputs are correct tells DSPy absolutely nothing about how to push to 80%. Also, how do you know which metrics to give to DSPy to pick for optimization? DSPy also relies on a few working examples that it can like synthesize accurate behavior from, but we don't want it to overfit on these few examples. And also, what if the queries for your model drift? Then you need to define a new set of working examples for DSPy to synthesize this sort of working behavior from. So in general, DSPy kind of pushes us away from this autonomous continuous improvement of your system prompts because it requires the user to manually figure out metrics that successfully measure your LLM outputs, as well as for you to figure out some examples that DSPy relies on to sort of synthesize this accurate behavior from, and just pushes us away from that autonomy that Karpathy was pushing. There's also simple meta prompting. And basically what meta prompting is you have a separate LLM, an optimizer LLM, and you ask this optimizer LLM to improve the prompt for the LLM that you are optimizing. So how this is done in practice is that you provide this optimizer LLM some metrics, so similar numeric metrics for DSPy, and you ask it to sort of improve this prompt. But you, again, run into the same problem that this numeric sort of metric that you're providing contains no information. It doesn't tell the optimizer LLM how to actually improve that prompt. It just tells it that it's only 70% good, make it better. And so the big picture question is, what do we feed into that optimizer LLM? Like Karpathy said, how do we allow your sort of LLM application built from your LLM, your optimizer LLM, how do we allow this application to natively figure out how to improve the prompt? And so in this push towards true native and autonomous prompt learning, Arise has come up with TextPro, which stands for Textual Feedback-Based Prompt Optimization, and it's sort of our push in this field of prompt learning. So TextPro is actually really inspired by reinforcement learning, so I'm going to be talking about reinforcement learning just as a comparison point. RL models are trained to pick an action based on a state, and the weights of the model are trained through these policy gradients or error terms based on that action. From one action and one error term is actually very little. Neural network-based models and reinforcement learning thrives from the fact that you do multiple iterations on your data, train on like a massive corpus of data. So all these little updates to your RL model over time, over so many different like passes on your data and large amounts of data will eventually push your model towards optimality. So again, just to be clear, the point I want to make here is that traditional RL requires a lot of data to work. So meta prompting, simple meta prompting works similar to reinforcement learning. Essentially, you have your LM application, it's going to give some output, and what you're optimizing now isn't the weights of the model, but the prompt of the model. And so this prompt is updated based on some numeric feedback from the model output. But as I was saying before, numeric feedback sucks. The LM has no idea what these metrics mean, and there's low information content. And so as a result, just like traditional reinforcement learning, you need a lot of data. You need a lot of data points to sort of push your optimizer LLM to update your system prompt over time. Because otherwise, because it sort of has no information or no guidance on how to actually improve the system prompt. So you run into the same problem as traditional RL. So now we introduce TextPro. TextPro uses the simple idea of using natural language feedback to optimize prompts. So instead of those numeric metrics that don't really mean anything, why don't we provide text descriptions of why the output is wrong or right, or a textual explanation, or some sort of annotation. So text is like way more expressive and flexible than some arbitrary error term, and because we know that LLMs are good at understanding text, why don't we guide our optimizer LLM with some actual textual feedback based on the result of the system prompt and the model. So just to be clear, there are three LLMs at hand. There's the LLM whose prompt we're optimizing. There's an annotator LLM, which is generating this textual feedback based on the output of your LLM. And you have this optimizer LLM, which takes in the feedback from your annotator LLM, and it's going to update the system prompt based on that textual feedback. So this way we have 4 key improvements. We have much better optimization because, again, you can provide this textual feedback, which is just so much more expressive and useful to an LLM. You also need far fewer data points. An LLM can improve a system prompt drastically just with a few or maybe even 1 data point because the feedback is way more expressive. It's actually in the form of text, so even just if one data point is lacking something that a lot of other data points are lacking, the feedback for that would be some text. The optimizer LM would see that, it would add that to the prompt, and now for every single other data point, it would be able to answer, or it would be able to function on that data point correctly. Also, if you want your LLM to learn from a lot of feedback in like one loop, it can do this as well. So let's say like you have a lot of feedback that you generate on all your data. You can pass all of this feedback on all your data into your optimizer LLM in one loop. And because we know LLMs are good at summarizing and understanding large corpuses of text, it can sort of condense all this feedback into what's necessary for the system prompt and do it in one loop. So in traditional RL, we need like so many loops over and over again over all of your data to sort of slowly push it. But here, because we're providing textual feedback, you can feed it all your data points, maybe even in one loop, and it can actually optimize your system prompt just in one loop. And another key benefit from this that I think is really important is that you have this transparency. Because your feedback is text, you can see exactly how your system prompt is being updated. You can see why it's being updated. You can see the things that are lacking in individual data points, and you can see how it's affecting your system prompt because it's all text that you can read and not some metric that doesn't mean anything. So let's look at an example optimization loop. Let's say the system prompt you start off with is generate a web page JSON for the following user input. Then we're going to generate the output for that with our LLM. So you can see here we have the input and the output. And now we're going to use our annotator LLM to sort of add our textual feedback. So we have an explanation which says the generator JSON is missing the required updated at timestamp field. We have an annotation which is sort of saying how the system prompt could be improved to address this. And we have some other forms of feedback as well. And so this all gets fed into the third LLM, the optimizer LLM, which reads this in one loop, and it just adds include the ISO 8601 timestamp as a field. So in just one loop, it was able to solve this problem. Now let's say we just passed in this sort of label, correctness, incorrect, right? Which would be sort of like a metric that we would pass into DSPy or into simple meta prompting. How would then optimizer LLM or any sort of system be able to figure out that what it needs is this ISO timestamp? So just in one loop, we're able to make some strong changes. It's easy, it's fast, and it's highly effective. And so I also wanted to make clear at one point that I talked about before. As you can see here, we have a batch of feedback data. So what if this batch was really big? Let's say you had like 1,000 data points and you're generating these annotations and feedback on all these data points. You can feed everything into your optimizer LLM, and it'll be able to take all of that text, because we know LLMs are great at summarizing text and handling large amounts of text. It can update the system prompt based on all of those data points in one loop. So it's way faster, and it's also just way more effective. So none of this really means something without some data to back it up. So is TextPro really better than other approaches for prompt optimization? So we wanted to do an experiment. And basically, the task for that is an agent is given a natural language description of a web page, and it has to make a JSON representation. How we're evaluating sort of like the LLM outputs is through a rule set. So we have a certain amount of rules that the output has to sort of satisfy. And the accuracy is the percent of the generated outputs that satisfy the rule set. And so the goal for our optimizers is to make a prompt that allows our LLM to generate outputs that satisfy the rule set. So for TextPro, these are the forms of textual feedback, rich textual feedback that were passed in that I talked about before, explanation, annotation, and the rule that was being violated from our rule set, as well as a correctness label. And so let's look at the data. So the first table has the number of rules we're checking for, the optimization method, the accuracy, and the number of API calls. So as you can see here, DSPy and regular meta prompting have staggeringly bad results. And this is because they have no way of learning that rule set. Even by passing in a metric that correlates with the rule set, so the accuracy, so the number of rules that were satisfied, DSPy and simple meta prompting cannot learn the rule set, which makes sense because the rule set is text. DSPy and simple meta prompting have no chance of understanding this text and making those changes in your system prompt. Also, you can see here the number of API calls. So TextPro only needs one API call to get to 71% accuracy, which is essentially like one loop of TextPro. Like at the same time, DSPy with 255 loops was not able to achieve 1% accuracy. And this experimentation is a little biased towards like rule set evaluation. But I will say that it's quite concerning that despite 255 API calls and using the entire data set, DSPy couldn't even learn a simple rule set of just 5 rules and generate outputs that could satisfy just 5 rules. And I also argue that textual rule sets is just a superior form of validation over outputs than some numeric metrics. So I think it's time we equip our prompt optimizers with the information they need to optimize prompts correctly. So just a quick summary of why TextPro is better. We have richer supervision since we're using this textual feedback instead of numeric metrics. We have lower latency. As I said, it can do it in just 1 or 2 loops rather than needing like a bunch of API calls. We also have higher sample efficiency, meaning that TextPro can use maybe just like a portion of your data set to optimize a prompt, while other methods would require multiple passes over the entire data set. We also have transparency in the way that your feedback is text, so you can see exactly what this feedback is. You can read it, and you can see how it's improving your prompt. And we also have this robustness in terms of all this feedback that we have here. It doesn't have to be in this format. You can pass any sort of textual feedback to your optimizer LLM, and because it's an LLM, it'll make some sense from that text, and it'll figure out how to optimize your prompt from that. So that's sort of like the robustness that comes with this as well. All right, so I'm going to give you guys a quick demo of prompt learning in the Arise platform, because you can do this right now in Arise. Okay, so the first thing I'm going to do is I'm going to make a prompt. Oh, God. Really? Oh, my God. Come on now. Right now? Really? Hard refresh. Jeez. Give me a second. No. Oh, really? Okay. Okay. I'm gonna try on a different network real quick.
While you're working on that, let me see if I can take some questions. By the way, did you guys hear the truck? That truck really wants to see this, so see if we can help the truck. All right, let's take some questions. Yes, hi.
So you go through this the system, and then you finally fine-tune the best prompts you have for, and then you finally want to put it in production. Now you want to decide, today I'm using this LLM, tomorrow I'm going to switch to another LLM. Then what?
Okay, so the question is, you've gone through the process, you put into production, now you want to switch to a different LLM.
Sure. Or I'm doing some kind of a metric where I'm going to leverage several, cost-benefit plan, whatever, and I'm going to switch between LLMs. Then what happens?
So within like the sort of the same application that you're collecting data on in Arise, if you change the LLM that you're using, you can still collect data on this in the same way. It'll still show up in Arise. So you'll see like all the different traces and the sort of the different data that's the inputs that are going into your LLMs, the outputs, the different tool calls. So all this will be the same. And so basically, I think to answer your question, you can, in the context of prompts, you have all that data and you have all those evaluations of your prompt with one LLM. But you can easily switch out another LLM, and you can test that same prompt in Arise. And so you can generate those like evaluation and those metrics on that new prompt, on the new LLM with the same prompt. And then you can see if you need to do some more optimization as well. So like all of that is sort of like all integrated within the platform.
But isn't what the SPI is supposed to, supposed to do is supposed to be able to get you a set of criteria that you can constantly, those are the ones that you would end up using with different LLMs to achieve the highest possible outcome, just because not every LLM will perform the same way for the same prompt.
Yeah, that makes sense. That DSPI sort of at the same time will do different optimizations to give you for different LLMs. So yeah, I guess you would have to do that per LLM with Arise prompt learning. So yeah, that's the difference. Yes, yeah.
Okay, you got a question right there?
Right.
So how do you know that you're converging?
Yeah, so yeah, with like traditional RL, obviously you have like gradient descent, right? So you know that it's converging with corresponding to some metrics. However, with this, there's no sort of guarantee of convergence, but I think you're not giving LLMs enough credit. I think if you provide some textual feedback to an optimizer LLM, it has very strong capabilities of improving a prompt, especially if you give it good textual feedback. For example, in this use case, we were telling it exactly which rules it was failing by using another LLM. So I think that sort of guarantee of convergence comes from the fact that LLMs like are intelligent. Mm-hmm.
How do you keep adding new test cases, or because every time you fix something, you don't know if it's going to
So
Yeah.
do you, sorry, I'm just doing this for the live recording. So do you keep adding new test cases?
Yeah, so the same sort of evaluation metrics and sort of testing that you are doing within Arise, you can keep doing the same testing just with a new prompt. If you want your new prompt to exhibit like different sort of behavior, which requires different evaluations, you can add those. But so the idea is that you're generating a new prompt that is supposed to be better at doing the same task that it's sort of written for.
Okay. And yeah, unfortunately, we do have to keep going. I know there's more questions, but Priyan, you going to be able to stick around for the end? Take more questions afterwards, or do you have to leave?
Yeah, sure.
Okay, great.
Yeah.
All right, awesome. All right, thank you very much, Priyan.
All right, so I'm going to introduce our next speaker. So So Ofer Manilovich is the developer advocate at Victara, and Victara is one of the earliest companies. We've started working with Ofer at LLM Avalanche. Who remembers? LLM Avalanche was the deepest, shortest, first technical conference on LLM. So we did it almost 2 years ago. In 4 hours, we did 4 tracks, like 50 speakers, and so Ofer was there. They were sponsors. And Ofer really kind of, you can meet him at a bunch of DevRel events. He's really good at explaining, I think, regional hallucinations and every single piece of the application building with AI. And I think he really kind of tackles the hardest problems. So one of the problems we have now, we have a bunch of RAG applications who uses RAG applications. Not really, not anybody. I can't believe this. Who is building RAG applications? Some people, all right? Who knows what RAG is? RAG is a few people, all right. Who knows what graph RAG is? Anybody? All right, cool. So the thing is, right, it's retrieval augmented generation, and you basically use your own documents for, context engineering, as they call it now. The problem is everybody says we have this kind of stuff. There is a bunch of startups. The question is, how do you rigorously evaluate it? And so when Ofer told me they actually proposed the benchmark, I thought this is awesome. This is really important for agents. Agents are going to use RAG. You need to figure out how are they doing. So Ofer is going to tell about it. Welcome, Ofer.
Thank you, Alexei. Thank you. Glad to be here today. And Priyan, just to say, I much prefer a demo that fails than no demo. So don't worry about it. It's all good. In meetups, I think we all developers, we know how this works. Next time, just pray a little bit harder to the demo gods. And by the way, I have a demo too, so we'll see if my demo gods' prayers are gonna work out. So a little bit about myself. Thank you, Alexei, for that introduction. I work for a company called Victara. I run developer relations. My background is in machine learning and AI for many years. And one of the things that I got fortunate to do is I used LLMs quite early, around 2019, early 2019, when GPT was just turned 2. So it's, before we all knew that this will be where it is today, so it's pretty interesting. And a little bit about Victara, we're, unlike Arise or Comet, we're not an observability company, we're RAG as a service. You can see some information about the company here. And we provide a RAG platform for trusted generative AI. And the 3 things we're kind of known for in this space is that it is a standardized platform, and a lot of people that use RAG in bigger companies know that there's this thing called RAG sprawl, where you have 15 different teams creating a RAG application, and at some point you say, okay, hold on, I can't have a stack of 15 different vector databases and 15 different orchestration frameworks, and et cetera. So having a standard platform is good for that. It's a standard API, so all developers can use the same API, develop applications that are secure, robust, et cetera. It deploys anywhere, so you can have it on as a SaaS service, but you can also install it on your VPC or on-premise with real hardware. And we really work hard on response quality, which will feed into my talk about Open RAG eval too. But we believe that retrieval is really important in RAG and in agentic RAG. And I'll mention a little bit about hallucination detection and correction, which is another interesting piece. So what is hallucination detection? That's something that's not very common, but became more common recently. It's essentially something where if you look at your RAG setup, this is an oversimplification, but you get a user query, you run it through your kind of retrieval system, you get some facts, you send them to the LM to get a response. The HHEM model essentially generates what's called a factual consistency score, which measures how much this response is actually grounded in the facts you provided. So the LM is a big model, it does a lot of different things. You think that you give it the right information, it'll actually create the right response, but that's not always the case. So that's a form of an eval that we've been doing for a number of years. In fact, we're by far the #1 downloaded model for hallucination detection on Hugging Face. I think it's now over 4.6 million since this image was created. Downloads on Hugging Face for the open weights version of that. And we have an interesting, if you're interested later, leaderboard, which rates different LLMs by their propensity to hallucinate in a RAG context. And so I have the links here for both of these. And it's called HHEM, the hallucination detection model. And just to mention, we recently launched a new thing called hallucination correction model. This is really interesting. So this takes it to the next step, which says, okay, I got a query, I got some facts, I got a response, and let's say I know that it's hallucinated, I measured it. So, okay, well, what do I do? So this solves that problem. It actually allows you to send it to this specialized model and get it corrected, so you get a corrected response, so it's really effective in that way. Okay, so I just wanted to mention a couple of things. I can talk about Victara forever, but I'm here to talk about RAG and Open RAG Eval and how it applies to agents. So, how many of you here said you use RAG in any way, or you know, okay, a little bit, maybe 10%, or build RAG systems, or know what RAG is at all? Anybody? Nobody? Okay, more. Okay, so one of the for those who raised their hands, how do you know if your RAG gives you bad answers? Right? It's a complicated topic. There's a lot of reasons it can give you a bad answer. It could be bad retrieval. It could be the LLM is not the right LLM. There's a lot of different problems with that. And so this is where RAG evaluation comes in. But RAG evaluation is kind of difficult. And it's difficult for a lot of different reasons. But three I want to mention is, one, that there's a lot of metrics. You might hear things about faithfulness and answer correctness and a lot of different metrics that are pretty popular. But it's sometimes confusing how they're defined and how to apply to them. The RAG system itself is very, sometimes not stable, and it's hard to understand how to apply it to your RAG system. But the one thing that's really the most difficult in practice is the fact that you need a gold data set. You need what are the right answers, what are the right chunks if you want to really measure against something. And that is in theory okay, but in practice really, really hard. So imagine you're even a really big company, and let's say you do have the resource or the cost to pay 3 people to go in and write the answers for like 1,000 questions you want to test on. Who knows that these people actually know the right answer? The answer could be in like 1,000 different documents. It could be very technically oriented to some hard. It's actually in practice really hard to get those data sets, and that creates a hurdle for scalability of this. And so I'm going to talk about how Open RAG Eval solves that in a minute, and that's the magic trick here. But I just want to make a notion about agentic RAG and agents, right? So agents make this problem even worse, the problem of evaluation. And I think as a community, we're starting to see some of the approaches for measuring agentic RAGs. There's this idea of, can I trust the tools? And the tools provide some output. Can I trust their output, right? There's the idea of chain of thought quality, like is the reasoning of the LM that drives the agentic behavior going to be trusted and get the right decisions in place? And then this idea of context engineering, which is like, what do I put in my context? What do I put? Do I put short-term memory, long-term memory? Do I put all the tool outputs or some of them? There's a lot of stuff around that, and a lot of more and more decisions to make, and therefore more and more reasons that we would really need to evaluate our systems in a way that's reliable and scalable. And so if you look at sort of the journey that companies usually go through in terms of agentic. So I think, in 2022, we were in ChatGPT moment. Everybody started using ChatGPT, and it was great. And that's still very popular. I use it all the time, or Anthropic, or Gemini. There's I think maybe a year and a half ago, people started doing this RAG DIY, trying to play with it, working through it. I think most companies are now in this enterprise RAG phase, where they're starting to put RAG into production, and they're sort of exploring stage 4, like what can agents do for us? What are the challenges? What are the issues? Some of them are more advanced than others, but I think we're kind of, especially for big mission critical things, it's like this. And then I think we definitely are going to get to this stage 5 sometime in the future, where there's going to be these autonomous agentic workflows we can trust. And I wanted to give this chart just to show that I think from a RAG evaluation perspective, people learn about it here, to sort of implement what they want kind of in this area. And when you start playing with agentics, you just want to run it continuously. You want to have it in every phase of the process. And when you do autonomous, you got to trust that your RAG evaluation framework is kind of automated too, because the agents have to go all the time. You got to be able to trust your metrics. Okay, so what is OpenRAG Eval? It's an open source package that is created with Vectara with really strong collaboration with the University of Waterloo. And so it's research-based backed, and I'm going to talk about what that means in a minute. But the important thing is it doesn't require the golden answers, and that's really key. That's the major kind of breakthrough here, or one of the major ones. And it allows you to not only measure your responses in a certain point in time, but also compare side by side. So it could be used for optimization, like, well, I can kind of configure my RAG system this way or that way, which one is best. You can sort of like do this kind of stuff all the time. Let me show you, now come the demo gods, but I'm going to try this out. This is kind of a UI that we've created to look at the outputs. I'm going to talk about how it's done in a minute, but I want to start with the end and show you what you get, right? This is a UI where you can upload your files after you run OpenRAG eval. And this is an example of comparing, side by side different options. So, and we'll talk about 4 different metrics. One is metric for retrieval, one is, and 3 for kind of generation. There's groundedness, which is how much is your generated answer grounded in the facts that were retrieved. Factuality, which is the hallucination detection, like did the answer make up stuff that wasn't there. And citations, a lot of people use citations in their RAG. We do this in Vectara too. And are the citations really correct, and are they correctly mentioned in the response? And what you can see here is that this is a run we did of two different runs of different configurations of the Vectara system. And you can see that it shows you each query and a lot of different details about the umbrella scores, which we'll talk about in a minute. You can look at the different retrieval metrics. You can look at the different groundedness and factuality metrics. So it gives you a really deep dive into everything that OpenRAG eval does. By the way, you can add more reports here and see like 3 or 4 of them, but I just wanted to, for simplicity, show you like the simple version here. And so it's really nice because it shows you can dig into each query if you like, but you also get kind of aggregated results here, so you can actually like click on, see which one is better and see where things are going. It's really helpful if you see a problem to debug and look at the query and see what happened, and then be able to say, oh, maybe I'm missing some data, or maybe my retriever is not good enough, or maybe our ranker is not good enough, or whatever it may be. Maybe I should use a different LLM, etc. Okay? So how does it work? What's the magic? Excuse me. So I'm going to talk about the 4 metrics I've shown you. The first one is called umbrella. Umbrella is a metric for kind of, again, reference-free retrieval evaluation. How does it work? It's actually pretty simple. So it's kind of an LLM as a judge, LLM prompt, special prompt. By the way, it's all open source. You can go look at the LLM. It's not secret. It's also in the papers that are based on this. And it actually ranks each chunk in your RAG system, each document that comes in, with whether it's relevant to the query or not. 0, 1, 2, and 3. And 3 is like it's totally answering the question exactly. 0, it's got nothing to do with the question, and you have gradations in the middle. Now you might think, well, that's great, Ofer, but I can do that too. Like, what's the big trick here? Well, the big trick is that the team here and University of Waterloo and G. Millin's team, they did a lot of research around this, and they've shown through extensive actual validation that the exact way that they prompted this, the exact way they implemented this, which is implemented in OpenRAG eval, is consistent with very extensive human annotations. So they did a lot of annotations in the track. If you guys are familiar, in the track conference, they had a lot of contests and things, and they collected this information on a particular data set. And they've shown that this umbrella score correlates very highly. And I encourage you to look at the paper. You see the sort of the correlation graphs and everything. And that's really what's powerful here. So you can trust that these things correlate with, these are the right chunks to retrieve. And they correlate with the query. Auto-nuggetizer is a kind of groundedness metric, and it's got 3 steps to it. I'm not going to go too much into detail because it's a little bit more complicated to explain, but generally, you create these nuggets, which think of those as atomic units of information from the chunks that you have. And then you classify these into vital nuggets or OK nuggets, they call them. And the vital nuggets are ones that you really want to have in the answer, and OK are like, they're OK, but not necessarily. And you kind of rank them. And then you really evaluate how much is your generated answer supported by the vital nuggets. Do many of them or all of them appear that? And so the score reflects that level of support. And again, you can see that across in the query and across all queries. Again, a metric that was validated across a lot of actual research and correlates with human judgment. The third one is citation faithfulness. This is really where, excuse me, we want to take the citations, and you want to, usually you show like a sentence and like the 1 or 2 or 3 citations at the end of it, another sentence in response and a couple other citations. That's the common format of showing citations. So you want to look at those citations and say, is the sentence really coming from there and is it supported? So it's a little bit of a more granular level of that. And again, there's a certain process here with 3 steps. And then hallucination detection, that's really kind of using HHEM, which is kind of the most powerful model there. Take the context, take the response, and output a consistency score, right? So we talked about this earlier. This is how it works. If you want to try it out, and I encourage you to try how to work it. You generate a set of queries. Again, just to emphasize the point, no need to generate any answers. Just generate a bunch of queries you want. You run it through a RAG connector, which connects to, we have connectors now to Vectara, LangChain, Llama Index. Very open to anybody who wants to contribute other connectors, please. We would very much welcome that. And the connector essentially collects the information from running each query against your RAG system, what responses you get, what chunks you get, everything in there. And then you get these outputs. Then OpenRAG-Eval essentially runs different evaluators, they're called, and evaluators are groupings of metrics that we saw. And it just runs them across everything, creates these RAG evaluation files, and those are the ones you saw that I just uploaded into the UI. You can look at the files themselves, but they're just, very tedious. So it's got a little bit more information and all the details you want, but really the UI is very fantastic to sort of see what's going on in a much easier way to understand. All right, and then the last thing I want to say is we just released today a new big PR for this package called consistency metric or consistency score. And that's really exciting because it measures whether your RAG responses are consistent, right? You really want this in regulated industries. For example, if you have an answer for a question, and when I get the answer, or when Alexa gets the answer, we get just different answers. Or maybe our retrieval suffers, and 1 out of 5 times it's not the same. It could be for a system reason, it could be for other reasons. So we have this thing called consistency adjusted index, and I'll show you that in a minute, and 2 other metrics for response consistency. And so this looks a little bit like this. Let me actually show you. I think I can show you this live too here. So yeah, demo gods are with me today. Thank you.
Yeah, somebody sent a picture.
What? Share a photo. Decline. Sorry. What was? I didn't see what I was doing. I thought you wanted me to. Oh. Okay. So, what is this showing you? So now, the idea about consistency metric is you run your RAG system through the connector like 5 times or 7 times or how many times you want, and it measures all these metrics around whether they're consistent or not. So you can imagine there's things like mean and standard deviation. We can have other metrics like median and IQR and things like this. But generally, you can see here that now we have this consistency adjusted index, which measures kind of an index across all of these different runs for each of these things we talked about: relevance, groundedness, factuality, and citations. And you can actually look at each one of those, each of the runs here, right? We only have 3 here, and kind of each of these becomes this. You can, I think, click on this and see a lot of the actual data. Like, this one was 2, and the values are all the same. Some other places, the values are different. So you can see how it gives you like a really nice, precise way to measure the consistency. So that's really what this is about. Really excited about this. This is literally released, I think, 10 a.m. this morning. And that's it. So to summarize again, pip install OpenRag eval. Would really welcome any feedback, any issues or PRs if you have any to contribute, and please give us a star. And here's some of my contact here if you want to connect. And thank you very much.
I think we have time for a couple questions, so raise your hand and I'll bring the mic to you if you have a question. All right.
Hi, and thank you for the sharing. I think this is very important. And I wonder how easy we can turn this kind of report into actions, because you have some comic mention that they actually have many reasons to make it fail. Maybe data quality is not good enough. Maybe it's the re-rank model. Like, I like your comic. So do you have any case can share that how to turn this report into the final actions?
That is a great question. Thank you for that. I don't have any particular specific ones, because I think it really depends on how you implemented your RAG system. I know that in our platform, this will be kind of semi-automated, but it really depends on what you use. Like if you use, again, it could be a systems reason, it could be the embedding model you use, it could be the chunking you do. There's so many reasons. So it really is system implementation dependent. And we're not, I don't think we planned on doing any particular extension in that sense, although that's a good idea. Maybe we'll think about it a little bit more. I think, though, generally, I would say one more thing about this is that it usually gives you a hint of where to look as an individual working on a RAG system. So you could see, oh, I get a lot of zeros on umbrella, nothing is relevant. You can say, wait, do I have the right documents in at all? Or if not, am I using the right ranker? So you can kind of figure out where in the system to configure and play with. You can quickly change that and rerun and test again, right? So, yeah.
Other questions?
How accurate is the eval, the initial nugget generation to like technical, like chip numbers, for example? Do you have experience with that? Because what I've seen is if you get RAG on like different chips, the exact number makes a difference, and it's like semantically matching to the wrong chip, for example.
Sorry, can you say that again?
Yeah.
Thank you.
How accurate is it to like very minute nuances to like technical stuff? For example, if it's like on chip information, one document might say like a certain number, and if it's a slightly different number, have you seen like experience with that? For context, like if it's very like ID numbers and things like that, right? Because sometimes you chunk it and the chunks may not belong to that. I don't know if that makes sense.
Right, so I think you asked like if you have very complicated data, like information about chips or...
Yeah, so you have like 2 lines of chips and they're like in parallel, right? They're like kind of similar, but it's like segmented.
Chips, you mean like chip design, like microchips? Yeah. So we actually work with a lot of manufacturing companies, and there's a broader answer to what you're asking was like, how do you do RAG for manufacturing, which is a really difficult problem. I get that, 100%. But I would say this for this particular thing. I don't know if I can say something specific to these types of documents, but because we have customers in this space, we do test it with their documents. You can imagine big, chip manufacturers or hardware manufacturers where you have images in PDFs, you have tables, you have lots of different things. But this this launched like 8 weeks ago, so I can't tell you that I have unfortunately, actual information to share, but I probably will have soon in the next few months. But again, please give us stars on GitHub because we want to spread the word around. It's a nascent project. We'd like all the love we can get.
Thank you, Ofer. Thank you, everybody. So now we promised to do announcements. We got all the speakers. However, if we have 3 spots, so 3 minutes, if you want to do a 60-second announcements, please come here, right? And we'll give you 60 seconds. Just line up here, so we'll need to do it very quickly. Anybody wants to do an announcement about anything, hiring, firing, building, product, ideas, co-founders? Anybody up for the announcement? Okay, we have Alex, one more. Well, okay. All right, so come here. Once we have everybody lined up, and somebody keep the time. Here, please stand in the middle. Here we go. So introduce yourself and tell us your idea.
Sure. So, hi, I'm Alex. I'm co-founder and chief product at a startup called Unicraft. We build something called unikernels, ultra lightweight virtual machines. We are building out a cloud platform. We do millisecond cold starts when AI agents, browserless or headless browsers, full IDE experiences. This is something that we're focusing a lot on these days. We're also rapidly hiring. If you have systems level engineering experience, Golang experience, or like love hacking on like hard optimization performance problems, then yeah, we'd love to have you. Yeah, thank you.
Thank you, Alex. So Unicraft, unikernels for agents, performance, super useful and important problem. Next one.
Hi everyone, my name is Mert. I lead recruiting for a company called Peregrine, and which is the way that we help public safety agencies revolutionize the way that they interact with their data. I'm hiring software engineers, senior software engineers, and engineering managers who have experience building agents, working with LLMs. If you look at peregrine.io, and if you have any question about that, I'm around. Please find me. Thank you.
Thank you.
Hi everyone, I'm Harnoor. I quit my job like 2 months ago. I just make YouTube videos. I have a podcast. I share tech knowledge, and I have 40,000 plus active listeners and over 1 million subscribers. If anyone wants to promote their AI agent product and showcase their knowledge on my channel, happy to feature any one of you all. And yeah, thank you. And you can connect me via Twitter or email me at hello@singinusa.com.
Thank you very much. Podcasts. Next one. I said 3. This looks much more than 3. Yeah. One more. One more? All right, we'll do one more.
Thank you. Thank you. Hi, everyone. I'm Sam, co-founder and CTO of Chroma. We're a Paris and New York-based startup. We just closed our seed round. We're building a multi-agentic system to automate IT tasks for mid-market companies. And we're recruiting 4 senior profiles, 2 senior full stack, and 2 senior AI engineers. So if you're in that field and looking for a job, come and see me, or my co-founder, Eloise, who's just there. Thank you.
All right, thank you very much. We'll do announcements.
Number 5 is in agent production.
Yeah, so this brings this amazing event to the close. The next one is going to be agents in production. It's going to be August 5th. We're going to have actual use cases. We see agents deployed, making money. Companies actually putting them in production. So this is going to be super awesome. Sign up, manage your RSVPs responsibly. Thank you everybody for the amazing event. And we have pizza and networking. Enjoy yourself. Come say hi. Hope you come and speak.